Hey guys, and welcome to the session. Today we're going to be taking a look at this. This is by Robert C. Martin, and it's called Clean Code. In my view, this is perhaps one of the most important books in programming, kind of in general. By that I mean, regardless of what language you're coming from, the concepts in this book can basically be applied to any language. Even though the examples in this aren't in Python, I don't think it really matters. The points carry across really nicely. The book itself is really good. It's really easy to read. The examples are really simple. And it outlines what I think are some really important practices. Some of them are, I guess, more obvious than others. And in this video, I want to go through the 3 chapters I think are the most important. Point number 1 is all about variable naming. Now, there's a kind of a famous quote. I kind of forgot the exact wording, but it relates to one of the hardest things in programming is just choosing what variables you're going to be having. And when I look back through my old code, I see things just like X, A, name, etc. And looking back through them now, with kind of no context, you realise kind of how stupid that idea is. Of course, the book goes into great detail talking about how you should be naming your variables. So let's cover a few of the basics, and then the idea is we can then flick into VS Code and look at some good examples and some bad examples in practice. You want your variables to be meaningful and descriptive. So let's suppose, for example, we're creating a new class, and this class is all about dealing with a person, and perhaps this class has methods to increase the person's age, or maybe change the second name or whatever. Suppose we took the increasing the age method. Now, if you just called this add age or move age by 1, those might be okay, but I think one kind of good way of doing this is, before just kind of going ahead and writing a method, have a really good think about maybe several different names for this method and choose the one that you think is the most painstakingly obvious and go for that. And also keep that kind of consistent amongst the class as well. I think the benefit of this is that, suppose you're writing this code, if someone else then comes to use your code, it's obvious to them as well. There's less kind of mental load for them trying to figure out your code if everything is really nicely, consistently named. 2, if you write this code, push it to Git, and maybe come back to it in like 6 months, it's easier for yourself as well. If you give it some kind of really stupid daft name, that's going to be much harder for you to kind of figure out what this method does in the first place and then carry on working with it. So meaningful, descriptive, intentional naming is a fantastic idea. And that's something that you can pick up right from the very get-go of coding. You haven't got to be an intermediate or an expert. You can do this right from day one. You also want to have variable names that are pronounceable and, interestingly, searchable. Sometimes in the industry, I do this a fair amount, is you have to kind of debug code, occasionally have to use grep or you have to use find to go through and find possible certain variables. Having them so they're searchable is actually a really good idea. So we'll show an example of this as well. But kind of think about not only making it meaningful and descriptive, think about if somebody wants to search through the code for, a certain piece of data, making it so that it's like search friendly is also quite a good idea. I guess this one's a bit harder to explain, but of course we will check out the example in just a minute. The book also recommends for class names using nouns, and then method names for those classes should be verbs as well. Suppose you have a program with like 4 or 5 different classes, they all have like 4 or 5 different methods. Using that same like convention amongst all of those classes, again, just adds to the overall consistency of your program. And the last one is to avoid mental mapping. And I think this probably relates back to the first point about them being kind of meaningful and descriptive. By avoiding mental mapping, we're talking about any kind of name that requires a bit of translation by the user. Suppose you had like a variable holding circumference. If you just called it C, well then you've got to try and work out what C means. But if you just call it circumference, yes, pain in the arse to type that out, right, and spell it correctly. But again, that pays dividends later on in your coding life, which is good. So I guess most of this chapter's kind of main philosophy is kind of taking more attention and more pride in what you call your variables right from the get-go. I guess it's saying like if you put in the investment and the time right at the start, it will pay dividends later on down the line when you come to edit, work, and maybe collaborate your code with other people. So let's jump into VS Code and we'll take a look at some good and some bad examples. Just a quick caveat, for my kind of function calls here, I've not actually made these functions, I've just kind of shown the call just to show like what it would look like. So ignore the rough format of telling me that this isn't defined. So, starting off from the top, we've got some meaningful and descriptive names. And I want to contrast this straight away with the bad example. So, These variables here I would consider fine. Total underscore price, written in snake case, and user underscore age. Descriptive, straight to the point, and give a clear indication as to what this actually means. On the flip side, if I was to rewrite these as this, so if I did TP and UA, I mean, like, I might know what this means from the start, but if someone was coming into this program brand new, they might have a hard time working out what this is, especially if it wasn't for this comment here. So this one is completely fine. I think it's obvious and straight to the point. Our next one is pronounceable names as well. So I think as well, like generation timestamp, it's obvious that this is a timestamp in its sort of Unix form. And our file path here, it's nice, pronounceable, simple, and straight to the point. To contrast this, suppose I did something like this here. I don't know why you would make a variable that looks like this, but I've seen plenty in my time. So any kind of example that looks like this, where your variable name is unpronounceable, I mean, this is really unsearchable as well. So yeah, really not good. Whereas opposed to this one here, this guy I think is completely searchable. If we had some code that was like retrying something and it was failing, it would be quite simple to search for retries, and then this would come up in your code pretty easily. As opposed to this guy here. So if we did retries as RT, I mean, yeah, we might know what it means if we wrote it, but of course, if someone else was trying to search for this issue, they'd probably have a hard time trying to think that RT meant retries. So this is bad, and I would argue that this is good here. This one, maximum retries. Now, in terms of keeping things consistent, suppose we had these as like free function calls here. So we're fetching user data, user info, user details, having the same like fetch user something, I think it's a really, really good idea. To contrast this, suppose you did like this here, like they all mean the same thing, but the fact that they're written inconsistently just makes for not a great experience. I mean, if we used like 3 different words to kind of mean the same thing, not good. I mean, the fact that like it works and like on a grand scale, there's nothing wrong with the code here. Following this principle of like making it as clean, as simple as possible, gives you a better time, and of course other people working with your code, they're going to be happy as well, that they're all written in a nice consistent way. Lastly, we have mental mapping. So I think I used circumference in the previous example. Suppose you had radius, but you'd done it like this. R equals 5. Yeah, it might take you a minute or two to work out what this R actually means. You have to go and ask someone. Whereas if you just write it as radius equals 5 straight away, no problem at all. It's nice, simple, and straight to the point. The second chapter I think is really good, is all about comments in code. Now, comments are super important, but what's interesting is that this chapter starts off by basically saying comments are a failure, which sounds a little bit silly, but effectively the point it's trying to make is if you're having to explain your code via comments, the code itself is not clear enough. Now, it does go on to say, actually, there are some caveats and you can use some comments, but I think that first bit makes a really interesting point. So rather than kind of writing some code and then making a comment to say, okay, this is calling this, I'm making this file open, etc. Maybe go through the code first and seeing if it's written as simply and as explicitly as it possibly can be before writing the comment. I think when I read this, it definitely gave me a bit of a mental shift to basically say, actually, maybe I could write less comments and just write better code in the first place. If your code has to be always explained by comments, is it really as clear as it possibly can be? But anyway, it does say you can use comments in certain situations. So let's talk about some good ways to use them and then some bad ways it recommends not using comments. The first one is legal related, a bit boring, right? But if there's any kind of legality or like license issues of your code, you might want to also put that in a comment, and that's completely fine. The next one is an explanation of intent. Now, this one I think is interesting because it kind of goes against the whole point of like, if the code's clear enough, why need a comment? But occasionally I think it warrants it where if you have to do something that's maybe really obscure or it's really kind of on the edge or like this is the only way this can be done, it argues that like a really simple sort of inline comment can be okay if it properly explains what that line is doing. Now the caveat here is, suppose this code gets updated, so does the comment in turn as well, and the book makes a good point that people tend to update the code, not really worry about the comments. So that's kind of like the trade-off you have here. You can have the comment in to explain this single line, but then you've kind of got this future debt where all future kind of code updates and reviews, etc., they also have to include this comment. So like, is this comment still relevant to the code? If that bit of code changes, it might be changed and made simpler, removing the comment, then that's perfect. But just make sure that if this code is changing, make sure that the comment also changes with it and that comment is still relevant to that piece of code. The next one is a to-do comment. These generally kind of come in, I guess, out of necessity. So suppose you're working on a project, you've run out of time, or you've got to move on to something else. Suppose you've implemented something, but in the back of your mind you think you can make this better, or there's some improvements to be made later on. A to-do could basically say like, this is currently working, but ideally I'd want to make changes X, Y, Z. So I'd say keep your to-dos minimal, only put them in where you really have to put them in. And again, just keep it like a single line, like saying like, yeah, this is working, but I want to make this particular change at some point in the future. And of course, when that change is done, get rid of the comment altogether. And the last one, which I think is probably a bit more kind of on the rare side, is a warning of consequence. So suppose you have a method that runs, it has some action, but maybe it has a particular side effect that maybe happens every now and then. This might be a good place where a comment might warrant going in. If it has some possibly unintended side effect, then I think it's probably best to kind of err on the side of this comment is okay to be here, because like not having a comment and then the side effect happening might be worse. So maybe it's like opening a certain file. You might put a comment in to say like, by the way, we're opening this file might be used by like 8-9 other people, so just be careful when this function is called. Now in terms of bad comments, it argues kind of like quite a few points as to what it thinks a bad comment is. The really important ones I think are fairly obvious. Anything that's like mumbling, goes on too much, or anything that is like redundant or doesn't really add any actual value to the code itself. Like if you had an add function, I just said like return a plus b, you wouldn't need a comment saying this returns a plus b because it's really obvious from the code. So whilst again for really, really kind of complicated functions, a little comment might be okay if it's warranted. If your code is simple enough, like leave the comments out. We don't really need to kind of have your code rehashed in a comment. We're just adding to the line count and to the complexity of the program. Another negative behavior in the world of comments as well is something I see quite a lot, is leaving commented out code inside. Now I guess there probably are some situations where this is absolutely crucial. Maybe like a method or a function is going to come in at some point, but doesn't need to be there now. But in general, I think commented out code, I completely agree with the book on this one, is generally a bad idea. Unless you've got like a burning absolute reason as to why it must be commented out, I'd get rid of it altogether, or maybe put it in a separate branch in Git or something like that. But commented out code can just lead to like confusion down the line. And I guess the thing I see the most here is I see commented out code and maybe that person has now left the company. You don't really know what it's doing, or should it be brought back in, or can it be deleted altogether? Like, we don't know. So commented out code from the offset, try and avoid altogether. Right, let's go into VS Code and we'll look at some examples of good and bad comments. Now, for our comments, I want to show two things which I think are kind of warranted and might be nice to do. Then we'll look at a couple of bad examples as well. So just suppose you had this example here. This is a fairly kind of common way to remove duplicates from a list and then kind of convert it back into a list, of course. So we pass items to the set function, thus removing duplicates, then pass it back into the list function to get back the kind of original list with the duplicates removed. Now, to a newer programmer, it might seem kind of weird that we're doing this. Like, why go from a list to a set to a list? Well, this might be a case where a kind of carefully, simply written comment might actually be okay. So if we said we're using a set to remove duplicates and maintain the unique values, I would argue that this is fine. Or for situations where it might not be entirely obvious what you're doing, but the thing you're doing is justified. Like, I would argue that going from a set into a list is a valid way to remove duplicates. But of course, to someone newer, it might seem kind of strange. So in this case, I think a comment is probably okay for this. But of course, this really is kind of dependent on who's writing the code and kind of where you are in your programming career. I mean, if you're super advanced, a comment might not be warranted here. But if I was writing some code for my students and I wanted to explain this, I would probably do this and leave it in. And secondly, things like this I think are fine. So in this case here, let's see what we got. We have a list that's being passed into this function here and then returning it. Well, this numbers.sort, if you do like the sorted function, it's not in place, we get a new copy. Numbers.sort is an in-place method which modifies a list in place. So after this, you can't really get back the original. I think any kind of action like this
might warrant a decent comment, especially if others are going to be using it and there might be some like unintended side effects. So things like opening files and modifying files, if they might be in use somewhere else, a similar thing might apply as well. But this is what I would generally do. I'd normally do warning and kind of block caps like this and write, oh, by the way, like here's a side effect to running this function. Now, for some bad examples, let's start off with this one. Now, a function that is really obvious like this, right? AB, return A plus B. This really doesn't need a comment. I guess the tricky thing here is knowing what level of difficulty requires a comment. I think that's different for everyone, but I think when something is kind of like this obvious, it's probably not needed unless you're like literally in your first kind of couple of weeks or months of programming. Next up, we've got this one here. So, function to do something. Oh yeah, of course, I mean, it's doing something, right? I've seen plenty of these in my time where we have like really vague comments that I've seen plenty of these in my time where we have comments that are like so vague, there's no like real point in them being there. I mean, if you wrote function to do something, I mean, yeah, it's true. It is a function that's doing something. This is processing data. It's doubling something and processing an item, but there's no value to this. If I was learning Python like from scratch, I would want to make this actually complement what is going on here. So I'll probably talk about the for loop. I'll talk about creating a new list and appending to it. Vague, kind of non-descriptive comments like this aren't helpful for anyone. And then we have just wrong comments. So this one we put sorts the list in descending order. Well, it doesn't. If you did like reverse equals true in here, then yeah, that'll be true. But this comment will be incorrect. Now this, I think, generally spawns from like people writing code, commenting it, and maybe later on that code kind of develops and gets changed and it evolves, and then the comments don't change with it. This can be like one cause of why you might see like comments that don't quite line up with what the code is actually doing. And if you were like a newbie in Python, you might see this and go, oh, okay, that's what it's doing, when actually it's incorrect. It's not descending, it's ascending order. And then this here, commented out code. Like, I mean, I suppose at one point this might have been put in, then we might have returned results. This is completely not needed. You know, we're just doing it here instead. So things like this, yeah, they can get straight in the bin. We don't need them.
And the last one, which I think is probably the most easiest to get done, mainly because of things like rough and all of the other various formatters out there, is the formatting of your code. So it's basically three things I want to discuss here. The first one is having, first of all, like a team agreement. So if you're working with lots of other people, you might have like an agreed way upon which code should be done. So in a group, I'd recommend having something like rough. You can have like a shared rough config, which explains all the formatting rules. And everyone would then just format their code according to the rules of like the rough formatter. That's a nice way of making it consistent and easy for everyone involved. Even just by yourself, I use rough like for my local projects, and just having rough there to kind of look over your shoulder and tell you off for certain formatting things is quite useful. Makes your code neat, consistent, tidy, and just a lot easier to read, which is nice. Now in terms of actual formatting, let's go for vertical formatting first. So your vertical formatting talks about like how your code is laid out from, say, top to bottom. Of course, we'll look at some examples, it's probably clearer there. But generally what we want to see is, first of all, your ordering. So suppose you have like 2 or 3 like high-level functions and maybe like 8 or 9 different utility ones. The high-level functions, the ones that are going to be the most important, put those right at the very top. So the most obvious to whoever's reading your code. All of the utility like helper functions, those would probably warrant going further down. In a sense, you can think of it a bit like a newspaper article. You've got like the most attention-grabbing thing right at the very top, like here's my main class. Then it goes kind of into like the more granular detail as it moves down. That's a little bit like how your code should run. Important, big stuff right at the top, or like the entry point to your code. As you move further down into the class or whatever, you've kind of got these kind of lower level functions right to the bottom. The book also argues for keeping closely related functions or methods together. So suppose we had a person class and we had a load of methods that just evolve around changing things like first name, second name, age. All these like changing methods, or they could be like property setters, they would benefit from all kind of going like in the same section. You know, if you had like 2 of them, 2 unrelated methods, and then like 2 more like property setters underneath, it just becomes like a pain to work with, where if you kind of have everything grouped nicely according to what they do, I think that's a much more nicer way of structuring your code. And lastly, we have vertical openness. And this is about just the spacing between your different things. Now, some formatters can kind of do this for you, but personally, I like to do things like 2 lines between my classes, maybe a line between each method. Whichever kind of system works for you, just make sure that system is consistent across all of your like modules or packages or projects or whatever. Lastly, we have horizontal formatting. This is just how your code is structured that way. So the most obvious one for this is line length. You can do normally anywhere between 80 and 120 characters. Just kind of choose what feels good for you. Make sure that's enforced. In the rough formatter and linter as well, you can put this in as an option, and then when you run the linter or formatter through, it will restructure or it will tell you off according to whatever rule you've chosen, which is good. You want to be using consistent indentation, so I normally do like a tab space for things like for loops or inside functions or whatever. Of course, you want to be adhering to PEP 8, so that's things like spaces between operators. Like if you did A plus B like with no spaces, just looks messy, it looks a bit silly, and rough will probably tell you off for it anyway, which is good.
To start off with, all of this is actually valid code. If I was to run this file, no errors. However, we've got a few issues here, and then we can then fix them using rough. So this first guy, functions aren't separated by blank lines. Some people actually might quite like the look of that. I personally don't. So if I was doing this properly, I'd be inclined to do it like this. Let's see, returning A and B, and then having like an actual line separating them here. So I'll put that back for a second. We'll see what rough thinks of it. There we go. Next up, we have inconsistent indentation here. So you can see, hopefully that's visible. If I zoom in a bit more, you can see how it's like just past the line here. Ideally, what I like is 4 spaces. So after this function here, I would do 4 spaces, then the for loop, and then like, 4 more, etc., and keep moving forward. Doing it like this, it's inconsistent, just isn't very nice. It doesn't make kind of like a nice viewing experience. So we'll let rough fix this and see how it comes out. And then finally, we have this here. So there's a number of things wrong here. There's no spacing around the operators. So like, check out this here. That's, oh no, not like that. So this here, I would ideally want a space here, a space here. I would want spacings here as well. This is also inconsistent with this. These aren't correctly spaced. And yeah, it doesn't look very good. And then finally, we have some lines that are too long. So whilst this is valid code, we have this fairly kind of long, like joined and statement. It's valid code. It doesn't look very good, and someone reading this isn't going to have a great time seeing that you've written this on purpose. So let's go ahead and put rough through this. So if I did rough, we have to do rough format, proper formatting, let it run, and there we go. Look at that, nicely separated. Indentation looks good. Separated these out, look at that. Nice, all separated, space here, and it's made it into a nice function with these put in the correct line. So that goes to show just how simple rough can make this whole process. And I think it's why, whilst the formatting is something you should pay attention to, it's nice knowing that rough can be there, kind of looking over your shoulder, kind of being a second set of eyes on your code. And that is all for today's video, guys. If you have any suggestions, or if you've read the Clean Code book, and you have anything that you think you've learned well, you think that's worth showing, feel free to ping us a message in the comments. I'll of course reply to all the comments as well. And I've also linked a copy of the book in the description down below as well. Cheers for watching, guys. Have a great weekend, and I'll see you all in the next video.